Hello friends, I am Amit Rami, and today we are going to see the Abaqus version issue. So when we make any file or when we make any thing in the Abaqus of higher version such as in 2024 or 2023, and then if we want to open it in a lower version of the Abaqus such as 2020 or 17 like that, then it shows issues. Okay, so it becomes difficult to open the CAE file. So we may just see that. Let us have an example. So first of all, we go to file and set the work directory. So let's see. So we are having the Abaqus file here, and we are having the simply supported 3D stress analysis. Open. Okay. And now we will just go to open file, and there it is showing a CAE. Okay, so that is I made this in 2022 version, and then I am opening it in a lower version. Okay, this is my 2021 Abaqus CAE, you can see here. Okay, so now we are going to open it in 2021, and was made, this file was made in 2022. So if we say okay, then what we see here, we can see that here it is written an error that the Abaqus file simply supported is from Abaqus CAE 2022. Okay, so I have made in the upper version, and now I am opening in this lower version 2021. So the current Abaqus CAE file installation must be upgraded before this model database can be opened. Okay, so this is the issue. This is showing this. So now what to do now? Okay, the CAE file if you are not opening, then what is the alternative? We have the alternative. Okay, what we have, if we have the .inp file there, okay, then it will help us. So how to get that? We will go to file, and then we will go to import. Okay, and then we will go to model. Okay, and just we will click here, and this is showing again the CI. We don't have to open CI. We will just go here, file filter. We will click here, and let's see there Abaqus input file .inp. I will click here. So we may see here job one UDL. Okay, that is .inp file. We'll just okay. Let's see. Okay, so now you will see here you get the beam. Just like CIE file when you open, you get this. You get from .inp file also. Okay. So now you can see here that you got your beam as it is. Okay, and once if you want to check all the things, okay, the boundary conditions and all, and loading conditions. So now you may go to job, you create a job. Okay, so suppose job UDL, you will run this code. Let's say submit. It's running. It will take some time, but I hope inshallah we'll get the result soon. Let's monitor. Okay, it's running. It's working. It will take some time, so we have to have patience for that. I think 1 to 2 minutes it will take. Still running. It's taking a lot of time. I think this is completed now. So yeah, it's completed. Let's see the results. So if we go to this, we may see. So first of all, we will just make it like this because this is the actual one. Okay, and now we will see here the displacements corresponding to U1. So we may see here this is a simply supported beam case and subjected to the uniformly distributed load, and how it is showing the zigzag pattern. Okay, the warping at the edges. Okay, maximum warping at the edges, and at the mid we will see that zero displacements. So we know that at the mid it is zero, and at the edges of the simply supported this is the maximum warping occurs. Okay, so that is the zigzag pattern we can observe from here. This is the zigzag pattern. Okay, so this we can see from here, and you may see other U2 along that direction, along y direction, and similarly U3. Okay, this is the vertical direction. So the load is applied on the top. So therefore, their maximum would be at the top. Okay, so you can see at the bottom it is lower concentration, but at upper edge it is higher. Okay, so due to the load applying at the top, therefore corresponding to that, the deformation is shown. So we may also plot this. Okay, so how we can do the plotting here? We can check the plot also. So we may do one thing. We may take tools and we will go to path, create. Okay, node list, continue. Let's do here. Let's add after. We will select the nodes. So if we want to see the displacement field, we may take on the edges. So at any edges, let's say in the edges this. Means it is a fine mesh. It is becoming difficult to just take all the nodes correctly. So there may be some error due to the wrong choosing of the nodes. Okay, because somewhere at the nodes and somewhere in between I have chosen. But even though, let's do it just for the sake of seeing the plot. Okay, so now I will go to XY data and I will go to path, continue, and this is path one what we have taken. Okay, in the uniform case, include all elements and or include intersection, let's say, and we are plotting with the z-axis. So we have the distance, and let's plot U3 first. So let's do this. So it is showing the U3 is 0 there, and we know that it is simply supported, so there would be no displacement along the downward direction. And if we go for U1 case, let's say, so U1 apply, okay, then plot. So let us see. Yeah, so we can see the zigzag pattern. Okay, this is our U1. So in plane displacement, so here the displacement is shown in the this axis. Okay, displacement in the y-axis in this direction, and the length of the beam is shown on this. Okay, so this is the case. So we have this plot, or we may have with respect to the z coordinate also we can see how it is plotting. So we may see this plot, like this. So you may observe this is a zigzag pattern. Okay, so we are getting the results for this in plane displacements. Okay, and similarly we may get the other results also. So we may get some other stresses, or let's say at the edges whether we get correct or not. Let's see. No, not at the edges we will get. So at the edges we are getting like this, but if we want to find, we may have this at the mid plane or somewhere, then we will get that results. Okay. So here we are getting the results like this. Okay, so we may get the correct results as where at which point we want to find. Okay, so we have seen how to find the results. Okay, in this way, and we have chosen at this edge left side. So nodes, so we may choose at the midpoint. Okay, and then we may get the results for the stresses like sigma xx, sigma yy at the midpoint or the mid of the beam. Okay, and then we can plot this space in the same way as we have plotted for the in-plane displacements. Okay, so we are closing here. Thank you.